Hello everyone, in this video we will see questions based on eigenvalues and eigenvectors. So this is the first question. Find eigenvalues and eigenvectors of the matrix 5, 4, 1, 2. So in the solution, first step is to find characteristic equation. To find characteristic equation for this 2 cross 2 matrix, we have two methods. One is regular method and another one is shortcut method. So in the regular method, what we are going to do, using this formula, determinant of a minus lambda I is equals to 0, we are going to find characteristic equation. So in this is the determinant symbol, a is the given matrix, lambda is the constant term, and I stands for identity matrix. So using this formula, easily we can find out characteristic equation. So this is the regular method. Next, another method is there, that is a shortcut formula. What is that shortcut formula? Lambda square minus a plus d into lambda plus determinant of a value is equals to 0. So this is the shortcut formula. Using this shortcut formula, easily we can find out the characteristic equation. So I am going to solve this given equation, this given question by using this shortcut method only. In that, remember, this a plus d stands for sum of diagonal elements. Sum of diagonal elements. So diagonal element means 5 and 2. So these two elements are going to call it as what? Diagonal elements, and this is the determinant. So we have to know how to solve determinant value using second order. Suppose this is one example, 2, 3, 1, 4. If you want to solve this question, we need to apply the second order rule. What is that second order rule? Cross multiplication, middle always minus sign, means 2 into 4, that is 8, middle minus sign, 1 into 3, that is 3. So 8 minus 3 is how much here? 5. So this is how we are going to solve second order determinant. So this rule in this shortcut formula we are going to apply. Therefore, in the solution, this given 2 cross 2 matrix we will consider as A. So A is equals to 5, 4, 1, 2. Next, write that shortcut characteristic equation formula. What is that? Lambda square minus a plus d into lambda plus determinant of a is equals to 0. So already I told you a plus d means sum of diagonal elements. Now substitute lambda square, I am going to keep it as it is. A is 5 plus d means 2 into lambda plus determinant of same value, that is a means 5, 4, 1, 2 is equals to 0. Now simplify. Lambda square as it is minus 5 plus 2 is 7 lambda plus, apply second order determinant rule. Just now what I said, cross multiplication. In that, this arrow mark, do the multiplication first. 5 into 2, 10, middle always minus sign. Next, remaining elements, do the multiplication. 1 into 4 is 4 is equals to 0. Therefore, lambda square minus 7 lambda plus 10 minus 4 is 6 is equals to 0. So this is nothing but characteristic equation. Lambda square minus 7 lambda plus 6 is equals to 0. So this is what we call it as what? Characteristic equation. Now using this characteristic equation we are going to find out this eigenvalues. So to find out that eigenvalues, either we need to apply the factorization method to find out the lambda values, that is eigenvalues, otherwise directly we can use the calculator. So here I am going to tell you how to use the calculator to get the eigenvalues. So for that, first press this mode button. So in that we need the equation. So next press 5, press 5. So in that we need to go with the quadratic equation, ax square plus bx plus c, because this characteristic equation looks like ax square plus bx plus c is equals to 0. Therefore, so next press 3. So press 3. So that time it will ask you a value, b value as well as c. A means this lambda square coefficient, nothing means 1. So press 1. Next is equals to b means coefficient of lambda, that is minus 7. Minus 7. Press is equals to c means 6. C means 6. Press is equals to. So that time the first value of lambda is 6. Therefore lambda is equals to 6, and one more value we will get. Second value of lambda is how much here? 1. Second lambda value is 1. So why we are getting here two values? Because in this characteristic equation highest power of lambda is 2. Therefore sure we will get how many values of lambda? 2 values of lambda. Therefore this lambda is equals to 6 or lambda is equals to 1. So these two are eigenvalues. So we got eigenvalues. Now next step is to find eigenvectors. So for that, take the matrix A minus lambda I into x is equals to 0. Correct? Using this we are going to find out eigenvectors. So remember here A means this given matrix 5 4 1 2, lambda means constant term, and I means identity matrix, and this x stands for column matrix which contains unknown variables, that is x and y. So I will tell how to find out this matrix value. So see how it is. Matrix A minus lambda I. A means given matrix. So what is that given matrix? 5 4 1 2. So write 5 4 1 2. Next minus, keep that constant lambda as it is. So I stands for identity matrix 1 0 0 1. Now multiply this. Therefore 5 4 1 2, I am going to keep it as it is, minus, keep it as it is, multiply by lambda, that is a constant term. Lambda into 1 lambda, lambda into 0 0 0, lambda into 1 is lambda, subtract. Therefore 5 minus lambda, first 5 minus lambda, 4 minus 0 means 4, 1 minus 0 means 1, 2 minus lambda, 2 minus lambda. Correct? So this is the matrix value. Which matrix value? A minus lambda I. Therefore directly how to write? For this diagonal elements directly subtract with lambda, that's it. Therefore see, directly write matrix. So for 5 subtract lambda and 2 subtract lambda. Only for diagonal elements subtract lambda, and remaining elements keep it as it is 1 and 4. Correct? Directly the same value you will get. 5 minus lambda, here Next 4, 4, 1 and 2 minus lambda. Clear? Next into column matrix. So this X stands for XY. This column matrix contains unknown variables X and Y is equals to 0. Now after this step, we need to solve for X and Y that gives us eigenvectors. Remember, for each eigenvalues, corresponding eigenvectors we will get. Correct? Corresponding eigenvectors we will get. That means for lambda is equals to 6, one eigenvector, and for lambda is equals to 1, another eigenvector. So let us find out eigenvector for lambda is equals to 6. Therefore, first write for lambda is equals to 6. So now what we need to do, in place of lambda substitute 6. Therefore this becomes 5 minus 6, 4, 1, 2 minus 6 into x, y, keep it as it is equals to 0. Next 5 minus 6 minus 1, 4 as it is, 1 as it is, 2 minus 6 means minus 4 into x, y, keep it as it is equals to 0. Now multiply these two matrix, row with column. Minus 1 into x is minus x, plus 4 into y is 4y is equals to 0. Next second row, first column, 1 into x is, that is x, minus 4 into y is minus 4y is equals to 0. So call this as equation number 1, and next call this as equation number 2. Now in these two equations we can take any one equation to find eigenvectors. So I will take the first equation. Therefore from 1, minus x plus 4y is equals to 0. So shift plus 4y to right hand side. Therefore minus x is equals to minus 4y. So after shifting, next make coefficient of x as well as coefficient of y as 1. Therefore what I am going to do is, either you can do the cross multiplication, otherwise directly dividing by minus 4. Here also divide by minus 4, and right hand side also divide by minus 4. So what will happen if I divide by minus 4? So that becomes minus x divided by minus 4 is equals to minus 4y divided by minus 4. Okay, so after that minus divided by minus is plus. Therefore x divided by 4 is equals to minus divided by minus is plus, and we can cancel 4 and 4. Therefore y divided by nothing means how much here, 1. So finally what we got, coefficient of x 1 as well as coefficient of y is 1. Therefore these two denominator values are nothing but eigenvectors. Therefore in matrix form x, y is equals to, so x denominator is 4, so right here 4, y denominator is 1. So these two are nothing but eigenvectors for lambda is equals to 6. Correct? For first value of eigenvalues. For lambda is equals to 6, we got eigenvectors 4 and 1. Now for lambda is equals to now for lambda is equals to 1, we have to find out. Therefore this same thing once again you write in matrix A minus lambda I into x is equals to 0. Therefore in matrix form 5 minus lambda 4, next 1 2 minus lambda is equals to 0. So into this x means column matrix x y is equals to 0. Now substitute lambda is equals to 1. Therefore 5 minus 1 4 1 2 minus 1 into x y is equals to 0. Therefore 5 minus 1 is 4 4 1 2 minus 1 is 1 into x y is equals to 0. Apply matrix multiplication 4 into x 4x plus 4 into y 4y is equals to 0. 1 into x, that is x, plus 1 into y, that is y, is equals to 0. Call this as equation number 1 and call this as equation number 2. So already I told you in these two equations we can take any one equation to find out eigenvectors. Therefore from 1 4x plus 4y is equals to 0. So now shift 4y to right hand side. Therefore 4x is equals to plus 4y becomes minus 4y. After shifting, next step is to make x coefficient 1 as well as y coefficient 1. Therefore either you can do the cross multiplication, otherwise directly you can divide by minus 4. See, both I will show you here. If you divide by minus 4, dividing by minus 4, what will happen? This becomes 4x divided by minus 4 is equals to minus 4y divided by minus 4. So 4 and 4 you just cancel, remaining is x divided by minus 1 is equals to minus divided by minus is plus, 4 and 4 get cancelled, so y divided by 1. So finally x coefficient we made it 1 and y coefficient is also 1. Therefore x y is equals to get eigenvectors we need to take the denominator values. So what is the x denominator value? Minus 1 right here, and y denominator value is plus 1. So this is what we call it as eigenvectors. Otherwise you can do the cross multiplication. Therefore this minus 4 comes in the denominator and this plus 4 comes here in the denominator. Therefore, or you can solve like this also. 4x is equals to minus 4y. So cross multiplication means x divided by this minus 4 comes here is equals to y divided by this 4 comes here. Correct? Therefore x coefficient is 1, y coefficient is 1. Therefore x y is equals to, write the denominator value. What is the x denominator? Minus 4. Y denominator is plus 4. So again these two are nothing but eigenvectors. So here we used to cancel 4 and 4, that's why we are getting here minus 1 and plus 1. Here we are not cancelling the values, therefore we are getting minus 4 and plus 4, both the values are correct. So this is how we are going to solve eigenvalues and eigenvectors.